my name's Knightz, and welcome back. Greetings everybody, my name's Knightz, and welcome back to another video, and we're doing another plugin tutorial, and I've realised that I haven't uploaded one of these in a while, and that's because I've been, trying to do, other things, and, this one is mainly going to be about, Java. There's not going to be a lot of bucket stuff in it, because it's important that you, know how to use, like, simple Java to be able to, do good plugins. So, I have made myself a lovely little, normal Java tutorial here with, SRC, Java tutorial and stuff. So, this is my main class. Every, ordinary Java file has to have this method in it, which is like the thing that gets run when you first run it. Now it looks a bit intimidating, but so I'll go through it now. So public means it can be accessed by any other file that doesn't have to be in the same package. So if I do make a test file and then I do Java tutorial. Hold on, main, you can see that we can access it from another class, and I believe it's in another package. Yeah, because it's public, so yeah, you can access it from another package. So that means you can either run it or like modify it. Or no, you can't exactly modify it without super complicated stuff, but you can run it from other files. Static, I'll get to that in a little bit because it's a little bit more complicated than most other stuff. But it's still simple enough. Void means it doesn't return anything. So if I had public int, where it returns an int, give me an int, return 3, that would mean we can do int gimme equals gimme an int, and then okay, needs to be static, but that would mean that it returns 3, so gimme is now 3. So that's void just means it doesn't return anything, so it yeah, it doesn't return anything. Now we're going to get into data types and things. Things for variables, although they're not really called variables. So we've got an int, which is a whole number because it's short for integer, which means whole number. You've got a double, which is a decimal number, like 3.14 for pi or whatever. You've got a boolean, which can be either true or false. So if I make this boolean 3, it won't like that. But if I make it false, it will like that. So let's just change it back to true, because true is much better than false usually. And I've also got a string, which is just text. So it can just be a number. It can be a weird symbol. It can be pretty much anything as long as it's in quotes. It can't be that or hello. If it's a string, it has to be in quote marks, or it can be null, which represents nothing. But if you make something null, then you can get lots of errors because you're trying to like do something to nothing, if you understand that. And you'll notice that all of these are in pink, except string, which is also spelt with a capital letter. Now, I'll get to that a little bit later, but basically it's because string, the string object or class, a string is a class file, like Java tutorial, and boolean, double, and int are not. You've got loads of others. You've got float, you've got byte, you've got long, you've got short, you've got, there's loads of others, but literally all they do is represent either, numbers that have bigger bounds or smaller bounds. For instance, if I do like that, it's too big, it's out of range. But if I make it a long, might still be too long. I can't remember the maximums off by heart, but it, even for an int, it's quite large, but for a long, it's larger. Then I can't remember, but basically, longs have more capacity, basically. So, now we're going to get to some less simple objects and data types, which are still used a lot. Also, these are what we call primitive data types, because they're like built into Java, and this is an object, because it is a class. So this is an array. An array is basically a structured list. So to make an array, you do the data type, so let's make an array of booleans. Then you do two close brackets. You can actually have more for a multi-dimensional array, but we'll do that in another episode. It's still fairly simple, but a bit too complex for this. So let's call this boolean array equals new boolean square brackets again. Then in curly brackets, you do whatever you want to have it in it, or whatever you want to have in it. So we can have true, false, true. Then just add a thing there. So sorry, I just auto structured there, auto formatted. But so this is a structured list. So if I do system.out.println boolean array, and then what one do we want to make it print? Also bear in mind that arrays start at 0, so this is 0, this is 1, and this is 2. And if I did 3, it would throw an error because it doesn't have a 3 in it. So let's do 1. And if I just run this here, it should print out false, because boolean array 1 is false. So that's an array. It's a structured list. However, we also have a an unstructured list. Or no, it's still structured, but you can change it. An array you can't change once you've made it. However, if I do list of strings, I can do add, I can do get, I can do remove. So you can edit a list. So to make a list, we do a list. Now this is where it gets a little bit complex. If you're doing a primitive data type list, so like a list of ints, you have to do its object's companion in a way. So I have to do integer here. It's usually the same, just with a capital letter. So I could do boolean, or I could do double. However, with int, it is integer. Or no, you've got to write integer. You can't do a list of ints. That doesn't work. As you will see, it's a misplaced construct. So you put you make a list. You put it in their lovely square braces. Or no, less than and more signs. I can't remember what that's called. So let's make a list of doubles. What should we call it? Double list equals new. You can do new lists, I think. Oh no, you can't. You do array lists, which is just what you do to make one. I'm not really going to explain that in this episode because it's a little bit complex, but yeah. And now we can do a double list add. You'll notice we've got to put a double in there. If we do 2, it won't like that because that's an integer and not a double because it doesn't have a decimal in it. But I can do 2.4 and it'll like that. Or I can do double 2, which is called casting, which is where you change one variable type to another. Now, you shouldn't always do this because it can glitch a bit. I'll demonstrate how casting really does in a minute. And then double list will now have 2 as its first value in it. And I don't really need to demonstrate that. It should be fairly simple. So let's just get rid of all of you for now. Okay. I'll get rid of these because all the other stuff is sort of needed. And so this is a hash map. Now a hash map is like a list, but think of it as a key value thing. So for instance, username and password. I'll try and demonstrate it now. I'm just trying to think how. Okay, I'm going to go into Paint. I'm going to show you basically what this does with some nice art skills. Pretty neato. So, key. God, this is horrible. Value. So, if my key was, for instance, 1. Now, a key can be whatever thing you want. It could be a string key. However, yeah, it could be a string key. So, if the key is 1, we might have hello set as the value for that key. It's like a list, but you use sort of like keywords to access the things you stored. You could also do string for username and password. So this is the username, and if I do a key value get, and then I put in whatever my username is, so like dank guy 123. If the hash map contained something, a key called dank guy 123, it would return whatever is stored in this. Hopefully that's not too confusing. So let's make one. Let's call it username. You'll notice it's the same way of doing it as you do a list, but you have to put 2 things in here, and you don't need to put anything in there because you've already put it in there. But you can do. So let's call it users because names are important to me. So let's do users put. So my username can be dank guy 123, and then my password will be I like memes. Now if I do system out.println users get dank guy 123, it will, oh, what's this then? Errors. Oh, right. That'll be why. Still commented. There. Run. Right, you'll notice I like memes has been printed because that is the person's password. Now, you wouldn't use a hash map for username and password because they're not very secure. I mean, you can literally just do about 1 line of code and get someone's password, which isn't a good idea. But, you get the idea, hopefully. So hash maps are structured lists where you can use a keyword to access a thing in the list. They're quite useful. Now we're going to go into basic loops, conditionals and stuff. So you've probably seen this in episode 1, and this is if. So basically what this does, you do if whatever you put in here, it has to return true for the code in here to be activated. So if I do if true, this will always function because true is always true, if you get what I mean. However, if I do if false, this won't happen. Why are you complaining? Oh, it's dead code because yeah, it's dead because Eclipse has worked out that it will never be ran. So let's make it if let's go back to our boolean here. So if true or false. Now we don't need to do equals true because it is a boolean, so it will only either equals true or false, and Java will already test for that. However, we could also do if integer equals 2, and because it does, that would return yes. And the code, so print line integer is 2. That would return. However, if we did 2.1, it wouldn't, because it's not 2.1, is it? It's 2. Now, what if we want to compare a string text? We can't do text because that won't work, because text is an object because it's a string rather than a primitive data type. So we have to compare using the fancy method that has been made. So we can do equals test. Let's just do it's test, and I'll demonstrate there. You'll see it's test. However, if I do text equals test, it won't work. It doesn't function because you can't use the equals to compare objects. You have to use their equals method, and every object will have that. Yes. Then we can do let's keep this code we've got right now, and we will also add else. So this stuff gets activated if this isn't true. So just it's not test because you can't use to compare objects. It's not test because you can't use to compare objects. Or of course you can do else if, which is like else. So this will I'm going to try and structure this a bit better. This else code will test text equals test. If this is not true, it will then go and test if this is true, and then if not, nope. So you can have as many else ifs as you want, but you can only have one else. So if I do else after that, it won't work. It doesn't like it. That's not how it works. But you can have as many else ifs if you want. However, if you want to do a lot of else ifs, it might be easier to do switch. Now, you probably saw this in the last video. I do believe I covered it. And it's basically a repeating, if this is this, then if not, check if it's this, if not, check if it's this, over and over again. So we can do switch integer Now, I've got a good way to explain this. Then you've got this switch thing here. It gets the value of integer. Then we've got case statements. So this is saying in the case that integer is 1, and I know it's got a colon there. It's a little bit inconsistent. However, curly brackets would be weird. Case 1. System 1. Then you've got to do break, because otherwise it would go on and do the next one below it, and so on and so on. So in the case that integer is 1, do this. Otherwise, or in the case that integer is 2, do whatever in here. So 2, and so on. And then you can have default, which is basically an else statement. It's saying if none of these cases are true, do this. So it ain't 1 or 2. And then if we try my lovely thing over here, you will see it printed 2 because it's 2. That's a switch statement, and we've also done else if, or if else if as it's called. So that's the main way to be checking for things. However, now we've got loops. So the first one I'm going to do is the while loop. So this, as I've said here, it repeatedly executes the code inside it as long as the thing inside the normal brackets or parentheses is true. So I've got a generic int here. So this is saying while int, or while I is less than 10, print I, and then increment I by 1, because otherwise we'd have an infinite loop, because I would never be changing, and it would always be less than 10, and then it would constantly be printing over and over and over again, and then the program would crash, most probably. So this makes sure that there's some change, and eventually it will reach 10. So, okay, let's give this a try. You will see, first it's 0, and because, how do I get the console back? Okay, never mind. Because I, in this case, is less than 10, it prints it out, 0. Then it adds 1 to it, and that is still less than 10. So it does that, then it does that, then, and so on and so on and so on. It then reaches 9, and it doesn't print out 10, because when I is 9, it's less than 10, yes, we print it out, and then we add 1 to it, and then we can't print 10 because that's not less than 10, is it? 10 is not less than 10. However, what if you wanted a while thing, however it always did the code once? Conveniently, we've got do while. So this is structured a little bit differently. So you've got do, curly brace, whatever code you want to do. Then you've got while x is less than 10. So I've been trying to think how to actually do this with numbers, and I'm thinking I'll just swap this around. So x, I've already done it, but this does x is 0, print x, and then add it by 1, then check if x is bigger than 10, and if it is, do this again and again and again. It's basically a while, but it's guaranteed to always execute once. So if I just get rid of you because you're causing unnecessary console spam, you'll see it printed 0 once in the do bit. Yeah. Now the main other loop we have is the for loop. So this basically, I'm not sure how to explain it, but I'm gonna try and spread it out a little bit. Can't zoom in, that's a shame. But basically, you do for bracket. You initialize a variable. You don't have to initialize a variable. You can use so I could use integer. Integer. However, so you've got to make it something. You can't just use its default value. However, we are making a new integer called p. We're saying do this code as long as p is smaller than 10, and then we're adding to p. So it's basically a while loop, but it's structured a little bit differently, and you can use it for a few different things rather than just numbers, and it's a little bit more compact. So that's the for loop. However, there's one more kind of a for loop that isn't technically a loop. Oh no, it is, but we're gonna make a new list strings in new list. Then let's just import that. Use java.util. Don't use java. Whatever the other thing is called. And we will also do strings, add hi, strings, add hello, string, add howdy. So we've got a list with 3 things in it now. What if we want to go through the list and either change things of it or in it, or just print everything out in the list? Because if I do system out.println strings, it won't look like we want it to do. It will look like that. But what if I want to just print all of the values? This is where the enhanced for loop, iteration loop, or for every loop comes in. So since it's a string, we're gonna do for every string called that we will call s in strings, do this. So this goes through every value in the list. It doesn't have to be in a list. You could do it in something else, but for every string in this case, because we can't really do int because it's a list of strings, then we will do this code. So we will do system out.println s, but we will do let's edit it a little bit. String s append. Oh yeah, you can use append, can't you? Oh, it is concat exclamation mark. So this will print out all of them with an exclamation mark added to the end. And let's run it and see. Hi, hello, howdy. Nice, isn't it? Very, very fancy. Just thinking about what we will do now. I don't think I'll set you any homework for this episode because it seems pointless. Like, I hope that you've know. Oh no, hold on. Let's relate this to Bucket a little bit. So in Bucket you have public boolean on command command sender command cmd string label string args. It's not liking those because I don't have bucket imported, but that's the on command thing. So if we do if sender instance of player system out print line you must be a player else player p equals player sender p dot send message hi player. So that's a very simple command, and what? Oh, okay, it doesn't seem to like that for some reason. Oh, right, it's because it's a method inside a method. That's why. But this is a super basic command. But I'm just going to try and explain what things actually are. So a command sender is any thing that can send a command. So a command block, a plugin, because plugins can execute commands. It can be an entity, and it can be a console, or it can be a player. We've got a command here, which is an object of what they actually typed. Label is just the actual message of what they typed, and string, we've got an an array of strings, which is the arguments after the command. And first we check if the sender is a player, but else we create a player object. Now objects are confusing, and I'm going to do an episode of them, which should be up within a day of the original video, if you're lucky, or within a day of this video, because I'm going to record it directly after. And objects are basically, this is a variable. That's why it has we're declaring it in the same way, and I want to focus mainly on this bit here. This is called casting, which I did demonstrate earlier. So, right. Oh, okay. That's nice, dear. Send an error. Right. Int number equals 2. List doubles equals new array list. Okay, there you go. This is a super simple thing. But what if we want to add doubles add number? It won't like that. It won't like it because it's not a double. But we can do casting, which, as I said earlier, it changes one variable type to another. So you can cast some things. You can't cast a so string s equals string number. You can't cast from int to string, or vice versa. It's usually only with numbers or objects that you can cast, but only if the object extends the right class, but that's complicated. Now, what if we do system out print line doubles get 0. So what if we print out the thing we've just added? Right, I want you to write in the comments if you think it will be 2 or you think it'll be 2.0. Okay, you done it? Okay, nice. 3, 2, 1, 2.0. Because we have made it a double, and a double can't not have a and decimal point in it. However, what if we do what if we cast it back to an int? You can't cast from double to int. I confound it. I knew that. But what if what if we tried to do a bit of math with a double and an int, so 2.3. What if we do system out print line number add doubles get 0. Oh, okay. 0. What do you think it will be? I want you to put in the comments what you think the answer will be. Will it be 2? Will it be 4.3? Will it be 4? Or will it be 5? Okay. 3, 2, 1. 4.3. But that's because I didn't even mean for it to be 4.3. That wasn't the intention. Okay. Right. Int second int equals, right, here we go, this should work now. What's going on here? Right then, we apparently can print to a, we can cast to an int here. I'm not sure why, but it's 4. Because it rounds down. Even if it's 2.99999. It will still round down to the nearest whole number if it is an int. And that's about it for this video. Thanks for watching. Leave a like if you enjoyed it. That would encourage me to make an episode 2. Maybe subscribe. That'd be nice. So, I bid you all farewell.